welcome back to my channel. Today I am starting group 3 for those who are preparing for IIT JAM, CSIRNET and KSET, GATE and many other entrance examinations. Okay, this video series are very helpful for all entrance exams, MSc entrance and PhD entrance exams and other entrance also. Okay, introduction of group 3. I am in this video I am discussing what is the meaning of group 3, and I am also solving some most important problems, okay, repeated in previous examinations. Okay, first of all I will start the introduction of group 3. Okay, what is the groups? Okay, first of all, what is the meaning of groups? Okay, let G be a non-empty set. Okay, groups means what? Groups is nothing. Groups is only a set. Okay, G be a non-empty set and star be any operation, then G comma star is a group if and only if the following axioms hold. Okay, that means what? Here G is a non-empty set. G means what? G is nothing but set only. Okay, G is nothing but set only. Okay, we take a operation. Okay, we take any operation. Star be here star be a any operation means star we take any operation. Suppose I am take star be a plus star be a minus star be a dividing and star be a what symmetric difference and star be a union, star be a intersection, anything we take any operation. Star be a multiplication operator. Okay, we take star be any operation. Okay, this should be satisfies this following axioms. Okay, first axiom is closure property. Okay, what closure property says means A comma B belongs to G. We take any elements in group G. Okay, in this group G. Okay, that implies A star B belongs to G. Okay, A star B belongs to G only. Okay, second axiom is associative law. Okay, we take any three elements in the group G. Okay, here A comma B comma C belongs to G, and A star B star C is equal to A star B star C. Okay, and third property is existence of identity. Okay, there exists a identity E. There exists E belongs to G such that A star E is equal to E star A is equal to A for all A belongs to G. Here E we call as identity element. Okay, and fourth axiom is inverse law or existence of inverse. Okay, for each A belongs to G. Okay, we take any element in the group G that exists a inverse element of that element in the G only. Okay, such that A star A inverse is equal to A star A inverse star A is equal to A only. Okay, it should be satisfies this condition. Okay, suppose we take some few examples related to groups. Okay, first of all I take if suppose n comma plus n comma star n comma dot here indicates multiplication operator. Okay, and we take z comma plus and z comma minus and q comma plus q comma dot q comma dot and r comma plus r comma dot. Okay, which these forms groups are not, we check it. Okay, suppose we take any elements in the this first of all, what is the first property? Closure property. We take any element in the natural numbers. Natural number starts from 1, 2, 3 and so on like this. We take any two elements 1, 2, we take 1 plus 2 is equal to 3. Yes, again this belongs to this group only. Okay, this satisfies, and this again, and this also satisfies associative property also. Okay, we check whether the identity elements presenting or not. Okay, what is the identity element of plus? 0 is the identity element for operation plus, but 0 is does not belongs to our group n comma plus. Therefore this n comma plus does not forms a group, does not forms a groups. Okay, if any axiom in these 4 axioms, any axiom fails, then that set does not forms a group. Okay, and second one, what is this n comma dot? Here we take any 2 elements that satisfies the closure property, associative property. And what is the identity element here? 1 is the identity element. Yes, this satisfies the identity element also, and this exists the inverse element. What is the condition for inverse here? A star A inverse is equal to E only. We know that identity A here. What is the operation here? Dot star here dot is equal to identity 1. What is the value we take here? We get 1. What is the value of what is the inverse element we take to this element to get 1? That is 1 by a. Suppose I take element 2. Okay, 2 belongs to n. Yes, 2 belongs to n, and 2 dot is equal to 1. What is the element we take here? We get 1 by 2. 2 to cancel, we get 1 identity. Okay, but 1 by 2 belongs to our set n? No, does not belongs to our set n. Therefore this is not a group. Okay, I hope you understand. Okay, Z, we comes to Z as this satisfies closure, and this satisfies associative also. This satisfies identity. Here 0 belongs to our set. Yes, 0 also satisfies, but inverse element does not satisfies. Here inverse element satisfies. Check it. Yes, element suppose what is there? A star A inverse is equal to identity was 0. Suppose we take any element. Suppose I take 1 belongs to our Z. I am taking here operation is plus 1. 1 plus what is the element we take? What is the element we take? Here inverse element we take, we get here 0. Tell me what is the inverse element we take here? We get identity elements 0. That is minus 1 we take. Yes, plus 1 plus minus 1 we get 0. Yes, we get here minus 1 belongs to our set Z. Yes, minus 1 belongs to our set, because what is the integers here? Tell me. 0 plus or minus 1 plus or minus 2 and so on. These are our integers. Minus 1 belongs to our integer again. Okay, therefore this satisfies all the axioms of our group. Therefore Z comma plus forms a group. Okay, I hope you understand. Okay, next Z comma minus forms the group. Tell me. Yes, tell me. Suppose what is the first axiom? Closure property, we take any elements in our Z. Suppose I am take 1 and minus 1. Okay, here what is the operation? Minus 1 minus and minus 1. We get 1 plus 1 is equal to 2 belongs to again integer. Yes, this satisfies our any element. We take any element in a Z, this satisfies the closure property. Now we check the associative properties also. Suppose I am take elements 1, 2, 3. We take any 3 elements in the our set Z. Okay, under the operation subtraction. Okay, suppose I am I am what is the condition here? 1 star 2 star 3 is equal to 1 star 2 star 3, that is we take like this. Okay, here what is the star here? Minus. Okay, 1 minus 2 minus 3 is equal to 1 minus 2 minus 3. This satisfies or not, we check it. Minus 1. Okay, we get here minus 1 and minus 3 is equal to 1 minus into here what is here minus 1 we get here, minus 1 minus 3 what we are get is minus 4. This is equal to 1 plus 1 we are get 2. Here minus 4, whether minus 4 is equal to 2? No, this is not equal to. The z comma minus does not satisfies the condition of associativity, therefore this is not forms a group. Okay, I hope you understand. Whether z n comma minus forms a group, tell me. N comma minus forms a group. We check closure property with this satisfies, but we check associative property. This is not satisfies. Okay, as well as this also not satisfies inverse property also. Okay, this not forms a group. Okay, whether q comma plus satisfies the our q comma plus is a group, tell me. Yes, tell me. Yes, closure property this is satisfies, and associative properties also satisfies. And what is the identity? Plus symbol is there, 0 is the identity, and inverse your this is satisfies inverse property. Yes, this satisfies the inverse property also. Okay, therefore this is this forms a group whether q comma in the set under operation multiplication is satisfies the group. No, this satisfies the group because this satisfies the closure property, associative property, and what is the identity? Here 1 is the identity, but for inverse 0 does not inverse of 0 does not exist. What is the 1 by 0 here? Infinity we get. Okay, the inverse of the 0 does not exist, therefore this does not satisfies the group. Okay, and whether q comma dot, okay, q star dot, that means what here? Except 0 all the elements present. Okay, except 0 all the elements are present. Okay, in the q, this satisfies the group. Yes, this satisfies the group properties and this forms a group. And r comma plus is a group. Yes, this satisfies all the conditions. Okay, and this satisfies the inverse identity, all the conditions, this forms a group. Okay, whether r comma dot satisfies a group? No, this not a form a group because 0 does not exist a inverse element in the r comma dot, therefore this is not a forms a group, but r star dot forms a group. Okay, these are the some few examples of group theory, and now I am discussing some most important problems asked in various examinations. Okay, and these examples clears all your doubts regarding groups. Okay, first problem is let G is equal to R except minus 1 defined this condition A star B is equal to A plus B plus AB is G comma star is a group. Okay, tell me how to prove this type of problem. Okay, we know that if the operation, if plus operation is there, we take identity element C is what? Here take 0. If dot is given, the identity element is 1. Okay, if here no, if the condition is mixing of plus as well as multiplication also, how to take the identity element here? How to take the identity element? Okay, first of all, how to prove this type of problems? Tell me. You have any idea? Okay, suppose I am proving this in generally. Okay, for this, okay, first of all, the first property what? closure property. Okay, suppose I am take any two elements in the group G. Okay, and also here what is the condition here is given? R minus except minus 1. That means what? Here A comma B belongs to what is group here? R minus except minus 1. Okay, that means what here? What is this condition says? Okay, A is not equal to minus 1 and B is not equal to minus 1. Okay, except minus 1, we take any elements of A comma B. That is the meaning of this. Yes or no? Yes. Then how to prove this? A plus 1 is not equal to 0. This minus comes this side. This minus comes to this side. We get B plus 1 is not equal to 0. And also we multiply these two. Okay, what is the condition? Okay, what we prove here? A star B is equal to A plus B plus AB. Yes or no? We multiply these two. A plus 1, B plus 1 is both are not equal to 0. And we multiply this. What we get here? AB plus A plus B plus 1 is not equal to 0. And what is this condition? What is this condition? A star B. This AB plus A plus B. What is this condition? A star B. Yes or no? A star B plus 1 is not equal to 0. That means A star B. This plus 1 is goes to that side. Here we get not equal to minus 1. Okay, what here? What is this? What is the meaning of this? Okay, A star B belongs to real R except minus 1. Okay, this is what they say. Okay, that means what? A star B belongs to G. Here A star B belongs to G. Closure property is satisfies. Yeah. We take in this set A, B, we take any element. This is the group operation star they given. Okay, this is the group, that is R minus except minus 1. Okay, we take any elements, that is we take A is equal to 1, B is equal to 2, or A is equal to minus 2 and B is equal to 3. Okay, we take any elements, this satisfies the closure property. Okay, we take any elements except minus 1, this satisfies the closure property. And what is the second property? Associative property. Okay, this is the R. We know that R comma plus and R except 0 dot satisfies the all the condition and this forms the group. We know that. That means what? This two are satisfies associative property also. This satisfies associative property also. We know that. Okay, that means what? Here except minus 1. Okay, this satisfies associative property also. Okay, we suppose we take any two elements. Suppose we take any three elements. Sorry, A dot B dot C. Okay, that this is the group, our group R minus except R except minus 1. Okay, suppose I am taking any two elements. A is equal to 1, B is equal to 2, C is equal to 3. We take it. Okay, this satisfies or not? A star B star C is equal to star B star C. That means what here? This is the condition for associative property. Okay, here A is 1 star 2 star 3 is equal to 1 star 2 star 3. Okay, this is we get. Okay, apply this condition. Apply to this condition. 1 star 2, that means here 1 plus 2 plus 1 into 2, 2 star 3. That means 2 2 4 1 5. 5 star 3. Here 5 star 3, what we get? 5 plus 3 plus 5 3s are 15. Okay, 23 we get. Here left side we get 23. Here right side we prove it. Okay, 1 star 2 star 3. Here 2 plus 3 plus 3 to the 6. Okay, that means 1 star. What we get here? 9 11 we get here. Yes, 1 star 11. That means 1 plus 11 into 11. Here 11 1 12 plus 11, we get 23 again. Here LHS is equal to RHS. Yes, this satisfies this. That means what? This satisfies associative property also. Okay, then in group theory, in competitive exams like IIT JAM and CSIRNET, KSET, in any other any entrance examination, we should first of all check the identity elements belongs to our set or not. Okay, and inverse element belongs to our set or not. First of all, we check this to 90 to 95%. Okay, they only concentrate on identity and inverse. Okay, maximum problems we eliminate by identity and inverse only. Okay, first of all, we check identity and inverse, whether the identity element belongs to our set or not, and inverse element belongs to our set or not. Okay, I hope you understand. Our associative property also satisfy. Here now we have most important property. Next is identity. How to prove identity for this type of problems? Okay, tell me how to prove it. How to prove identity for this type of problems? Okay, third property is identity. This is the most important. Okay, suppose E is the identity. E is the identity. Yes or no? Identity of our group G. Okay, this is the identity and this is our group G. Okay, G comma star. Okay, what is the condition? That is, we know that the condition. What is the condition? A star is equal to A. We know that. What is the given condition they given? What is the condition they given? A plus A star B is equal to A plus B plus AB. Okay, we apply here A plus E plus A is equal to A. Here A get cancelled. We get E plus A is equal to 0. And here we take E common. 1 plus A is equal to 0. Here what is if this in these elements anyone is 0, then we get this equal to 0 only. That means what? Here A is equal to 0 or E is equal to 0 or 1 plus A is equal to 0. Okay, yes or no? What is our group? R minus except minus 1. Okay, this is not possible. This is not possible. 1 plus A is equal to 0 because A is equal to minus 1 we get, but our set minus 1 does not belongs. Okay, that means what? This becomes 0. This becomes 0. Okay, we get E is equal to 0. That means what? Here identity element is identity element of G is 0. Okay, then we have to find the inverse element. Okay, the fourth point is inverse element in G. Let we take A belongs to G. Suppose A inverse be its inverse. Suppose here A inverse be its inverse. Okay, we know that what is the condition for inverse? A star A inverse is equal to E, and A star A inverse here identity element what here? 0. Okay, then we apply the given condition. A plus A inverse plus A into A inverse is equal to 0 we get. Okay, then what we get here? A inverse plus A into A inverse is equal to minus A we get, and we take A inverse common. 1 plus A is equal to minus A we get. Okay, then what we get? A inverse is equal to minus A by 1 plus A. This comes to denominator 1 plus A. This is belongs to G. Yes, this is belongs to G because here A, suppose if you take A is equal to minus 1, denominator becomes 0, but here A minus 1 does not belongs to our G. that means R minus except minus 1 is our group. Okay, that means except minus 1 we take any elements of A. Okay, that means what? This belongs to our group G only. Okay, this is the element A inverse is equal to minus A by 1 plus A. Okay, this is our that means what? This is our inverse element. Suppose what is the identity? Suppose this is the 0 is the identity. Suppose we find the inverse element of 2. They ask the question like this: we have to find the inverse element of 2. Okay, then what we find? 2 inverse is equal to minus 2 by 1 plus 2. That means minus 2 by 2 plus 1 3. Yes, minus 2 by 3 is belongs to our group G. Okay, like this we have to find the this type of problems. Okay, second problem is related to matrices. Let G is equal to set up matrix. The matrix is given A comma 0 comma 0. Okay, here where A belongs to R except 0. Show that G is a group with respect to matrix multiplication. Matrix multiplication. Okay, this forms the group or not? Okay, I am here problem 2, question number 2. Here closure property, this should be satisfies. And okay, suppose we take any elements. Suppose we take A 0 0 0 and B 0 0 0, and what we get here, if you multiply this to A 0 0 0 and B 0 0 0, A B 0 0 0, we get again this belongs to 0. This belongs to G. Okay, this belongs to our group G only. Okay, that means this satisfies the closure property, and this also satisfies the associative property. We take again other elements, other matrix like C 0 0 0. We apply the property of associativity. This satisfies the associative property also. Now our main focus on identity and inverse element. Okay, how to find the identity element and inverse of this group? Okay, suppose E comma 0 0 be the identity element, identity of G. Okay, here what is the condition? A star E is equal to E. This is the condition, we know that. Okay, same here apply here. Here A 0 0 0. Okay, here multiplication is given. Multiplication E 0 0 0 is equal to what? Suppose in general, suppose we take other example also. Suppose I am take 1 0 0 0. Okay, suppose in place of A we take 1. Okay, we take it or not? Yes, this is also 1 is also element. Okay, 1 0 0 E 0 0. Okay, we multiply it E 0 1 0 0 0. Okay, E 0 0 0, this is equal to 1 0 0 0. That means E is equal to what here? 1. Okay, that means what is the identity here? E 0 0. That means the identity element is 1 0 0. Okay, suppose we take other in the group G comma dot. Okay, in the group we take, suppose a 5 0 0, we take 5 0 0. Okay, in place of in general they given A. Okay, I am taking elements in the group. Okay, I am taking element 5 0 0 0. Okay, we check it. This gives the identity or not. Okay, 5 0 0 and E 0 0 is equal to 5 0 0 0. This means what? 5 E 0 0 0. That means 5 0 0 0. That means 5 E is equal to 5. E is equal to 1. Okay, that means what here? What we get here? Identity element here. This is our assumed identity. That means what here? E is equal to 1. That means 1 0 0 0 is the identity element for the this group G. Okay, this group G. Now we have to find the inverse element. Okay, how to find the inverse element of this group G? Okay, suppose I am considering A inverse 0 0 0 is the inverse of A 0 0 0. Okay, we take like this. Okay, that means what is the condition? A star A inverse is equal to E. This is the condition, we know that. That means what? A 0 0 0 is equal to A inverse 0 0 0. This is what is the identity? 1 0 0 0. This is the identity we get. Okay, multiply this, what we get? A inverse 0 0 0. This is equal to 1 0 0 0. That means A inverse is equal to 1. A inverse is equal to 1 by A. Okay, and here A is not equal to 0 because they given the condition R minus except 0. Okay, that means what here? A is equal to R minus except. This is the meaning. Okay, A not equal to 0 A not equal to 0 means what? Okay, except 0 we take any values of R. Okay, R minus except 0. Okay, that means what is the inverse here? This is our assumed inverse. That means in A inverse means 1 by A 0 0 0. Okay, this is the our inverse of the group G. Suppose we take suppose they ask that we have to find the inverse element of 6. Okay, how to write? 1 by 6 0 0 0 belongs to R minus except 0. Okay, this is our inverse element of R 6 0 0 0. Okay, like this we solve this type of problem. Okay, next problem is let G is equal to A 0 and A belongs to R except 0. Show that G dot is a group. Okay, that means group with respect to matrix multiplication. Okay, like this in our previous problem. Okay, here these three elements are 0, but here in this only one element is 0 is given. Okay, I am directly solving the identity element and inverse only. Okay, what is the identity? Suppose I am considering E 0 is the identity element. Okay, for the group G. Okay, for the group G, and what is the condition? A star E is equal to, tell me, A. Okay, this is the condition. Suppose in the group I am taking 1 1 1 0 with taking element okay 1 1 1 0, and that is identity E 0 is equal to 1 1 1 0. Okay, multiply this, what we get here? E plus E 0 and E 0 E 0. Okay, this is equal to 1 1 1 0. That means 2E is equal to 1 and E is equal to 1, or 2 is equal to 1 only. Yeah, that means E is equal to 1 by 2 and E is equal to 1. 2E is equal to 1 by 2 and E is equal to 1. Okay, we suppose we take here small correction here. The problem is A only. Okay, this is not a 0. Okay, in this place. Okay, all the elements are A only. Okay, that means what? That means what we get? Okay, what is the identity we get here? A. Okay, this satisfies the closure property or not? We check it. A we take B and belongs to group G, and 2AB we get. This again belongs to G. That means this satisfies the closure property, and this also satisfies associative property also. Okay, now we check the identity property. Suppose I am taking E is the identity element of the group G, and suppose I am taking 1 1 1 is the element of the group. Okay, here E multiply with 1 1 1. Okay, we get is equal to 1 1 1. We multiply with this, so we get 2E is equal to 1 1 1. That means 2E is equal to 1, E is equal to 1 by 2. That means the identity element is 1 by 2, 1 by 2, 1 by 2, 1 by 2 is the identity element of the this type of group G. And the what is the inverse of this group? Okay, what is the inverse of this group? Suppose A inverse, A inverse, A inverse, A inverse is the inverse of the group, and A into A inverse, A inverse, A inverse, A inverse into 1 by 2, 1 by 2, 1 by 2, 1 by 2. We this equal to 1 by 2. Okay, this is identity. Now this is the condition. We know that A star A inverse is equal to E. According to this condition, we take the element and inverse element and identity. Okay, we multiply with this, what we get? 2A inverse, 2A inverse, and 2A inverse, 2A inverse, and with this equal to 1 by 2, 1 by 2, 1 by 2, and A inverse, 2A inverse is equal to 1 by 2, and A inverse is equal to 1 by 2. Sorry, 2 to the 4A. Okay, that means the inverse element is what? 1 by 4A, 1 by 4A, 1 by 4A, 1 by 4A is the inverse element of the this type of group G. Okay, I hope you understand the this type of group. Okay, this next problem is, let G is equal to 1 comma minus 1 comma I comma minus I such that G comma dot is a group or not. Okay, suppose any finite group is given, that time we draw a closure chart. Okay, what is the closure chart we draw here? Okay, if any finite group is given, that time we draw a closure chart. Okay, 1 minus 1 identity minus I. Okay, 1 minus 1 I minus I. Sorry, star is there. Okay, sorry, we draw here. Okay. Okay, what we get here? 1 and minus 1 and identity minus I, 1 minus 1 I minus I. Here dot is the operation is given. Okay, 1 dot 1 is 1, 1 dot minus 1 minus 1, 1 dot I, 1 dot minus I is minus I. Okay, minus 1 dot I minus 1, minus 1 dot minus 1 is 1, minus 1 I is minus I, minus minus plus and I we get here. Okay, I minus I square means what? Minus 1, minus I square is what? 1. Okay, minus I minus I square is 1, minus 1 here we get. Okay, this is minus I, this is minus I, this is I, this is I. Okay, I square is 1 minus 1, minus 1 minus plus 1, and minus I into minus I is we get minus 1. Okay, this satisfies the closure property. Yes, we take any two elements we get. Again again we get the same element in the, again we get the element in the we get the element belongs to that group G only. Okay, this satisfies the associative properties. Yes, this satisfies the associative property also. We take any three elements in the group G. Okay, then we get the that belongs to then that element satisfies the associative property, and that gives the that belongs to our group G only. Okay, this satisfies the, and what is the identity element here? What is the identity element here? Okay, what is the identity element here? To find identity element here, suppose any element in the group G that gives the all the elements. Okay, all the elements in the our group and at the same order. Okay, at the same order, that means you are observed that this is the order 1 minus 1 I minus I is the order. If the any one is the identity that gives the same order, see this here, 1 minus 1 I minus I, that means this is the identity, 1 is the identity element here for this group. Okay, and what is the inverse element here? Okay, that means here per 1 the inverse element is 1 only, and minus 1 for minus 1 the inverse element is minus 1, and for I the inverse element is minus I, and minus I for minus I the inverse element is I. Okay, now we understand the this problem. Okay, this satisfies the all the axioms of the group. That means this forms a group. Okay, we know that x square minus 1 what here is equal to 0. This is a polynomial. We know that second degree polynomial. That means x is equal to 1 minus 1 is the roots, and x cube minus 1 is equal to 0. That means what, x is equal to 1 omega square is the roots. We know that x for a 4 minus 1 is equal to 0. That means what is the roots, x is equal to 1 comma minus 1 comma I comma minus I iota. Okay, this set of solutions of the nth root, okay, nth root of unity, okay, forms a group. Okay, now we have to observe like this. Okay, the set of nth root of unity forms a group. Okay, we write down one important note. Okay, let G be the collection of solutions of equation x power of n minus 1 is equal to 0. Then G comma dot is a group. Okay, or we write down this statement like this also. The collection of nth root of unity always forms a group. Okay, this is the introduction of group theory. Okay, in this video we learned a lot about group theory, some examples and some most important examples, and how to find the identity and how to find the inverse element. Okay, we learned this type this all in this video. Okay, in next video I am discussing some special types of groups, okay, and properties of that groups, okay, examples of groups. Okay, thanks for watching. If you like the video, please share to your friends and subscribe my channel. Thank you.